few seconds for everything being arranged properly, and we will start. So the topics today's lecture included multiple question, and among them it's mathematical statistical data analysis in medicine, biostatistics methods as background for evidence-based medicine. In fact, we will talking only about introduction into these methods because it's a very broad area. But before we will start with main question of lecture, with statistical analysis, few minutes we have to pay attention for possible to use application software, and I prefer to use spreadsheet like Microsoft Excel as example because of their simplicity and availability. It's not the best software for statistical analysis, but it's simple and widely available. So then I will talking about some basic statistical calculation, and most important will be regressional hypothesis testing, and then if we will have enough time, I will try to get into correlation regressional analysis if possible. If not, I will postpone this for next lecture. And I will try to use spreadsheet as example tool for demonstration, but as I already said, significant attention will be paid for theoretical question. First of all, because they obviously most important. So just minimal points which is required to be known, or if you already have experience, made some updates with a spreadsheet, it's their calculation ability. In fact, major purpose of spreadsheet application all the time it's done calculations. So obviously with Microsoft Excel or Excel Cloud Excel or Google Spreadsheet, they are dedicated for same purpose as well. And here is, we immediately start with formulas, because it should be obvious how to input value, like put necessary numbers into cell. But if you want to make some calculation, so we have to follow dedicated syntaxes, which is very common among different spreadsheet applications. So here is we have simple equation which start with equal sign. It's tell any spreadsheet that it will be equation followed by it. Then we place our arguments for education. As arguments could be used constant, we can put directly value in our equation, mathematical and logical operators like addition, division, etc. Necessary brackets to follow proper mathematical order of operation. And more efficient way to get data is to refer to cell which contain data. Here is used character by number methods of referring, but also modern spreadsheet use R1, C1 notation, row column notation, but which actually there is no difference. What is actually for me a little bit strange every time in spreadsheets that they partially translated their function. There, by intention, I put there this picture which contain two different functions. It's from Russian version and Ukrainian version of spreadsheet, which have like abs function, which is not translated in an original name. And here is we have a sqrt function, which is in some reason being translated into national language. So Ukrainian, Russian, Polish, German, etc. So here is, as for me, most difficult part, because every time you will have to check documentation or current environment to evaluate what actual name of this function have to be used for a particular calculation. Anyway, usually we can create more complex creation which contains multiply function, multiply arguments with mathematical operation between. And here is even have more function because we have nested function. As you can see inside square root, we have power of 2, which is actually internal function, but this time declared as operator. So here is one syntaxes and more detailed if necessary. And by extending, we can add some additional kind of arguments because some more complex function required more complex arguments. Like in this case, we have a function which which require to be provided arrays of arguments or ranges. As you can see, it's separated by colon. And multiply arguments of the same function separated usually by comma. Again, have to be evaluated because depending on national settings, argument separator could be changed from comma to semicolon, depending to again regional settings. So have to be careful with these things. But in this case, as you can see, function operate through two arguments, and each arguments represent array. So range of cell from starting point till to ending point. And here is what do we have there. As you can see at the bottom, we have even additional case when you going to use specific function, usually our spreadsheet give for you hints about syntaxes of it, and so you could be aware at which part of equation you are already right now and what you which arguments you have to provide. Again, what is I want to make the emphasis when you will deal with spreadsheet, you must strictly follow syntaxes of demand of syntaxes for those application. Okay, one more case, we will have specific kind of array function which could be not only expecting arguments as array, but in fact, entire function array itself could be operated for a range of cell at a time with a specific array constant will be consequently operated by each one of this cell. So here is we will have like we'll have summation of this from A1 to H1 cells, which will be multiplied by 1, 2, 3, and so on, constants for each next cell. So here is we have a very maybe rare case, but useful as well. Okay, so this and small extension for arguments. As I already said, constants we can put directly value. We put directly into equation, like text or numbers. Do it only if it have to be used only one time. Only one time. If you have your own constant which have to be reused multiple time, put into spreadsheet and use a reference to cell, which actually could be addressed to cell like a column label row number. And usually we deal with relative reference like given, but in case you want to refer every time particular cell, it has to be absolute reference, like which we use $sign to append column label, row number, or both. Like in this case, we refer specific cell. If you have some kind of constant, place it there, and you can refer it multiply time, and it will be not update when you move equation around. So it will be every time point to the cell. Other hand, it will be changed when you will make your calculation. Maybe I will show this example later among statistical example I will provide. Same way we can refer only column or only row with given example. And about arguments, final words about arguments, arrays and set. They could be supplied and have to be supplied for a lot of calculation, especially if we are talking about statistical calculations. So in array, separator used colon. In set, separator usually used semicolon. Except situation when it's have to be used as arguments delimiter, so then commas, I remember. Here is we are given example of what it will be included into array, or how we can compose two different part of arrays into single set. So here is I would recommend even maybe take some notice or screenshot about this, because on your practical classes, it will be you will need to few time deal with such points, provided like especially more almost all statistical function required providing data array as arguments. Our spreadsheet have some kind of automation tool, for example, insert function wizard, which is still available even modern spreadsheet, a modern Excel version, which is provide two-step dialog, and despite interface and icons, toolbars, everything significantly changed in modern spreadsheet version, this to Windows does not. So they remain the same. First one, you can, if you don't exactly know what kind of function you have to use, you can make search, you can review category and check and find out and select necessary functions. Second stage, you provide arguments manually arrange or by picking from a worksheet, and at the same time you will be given explanation what this function do and expected results, so you can verify you're correct. Very helpful tool, and like more or less spreadsheet have something the same. So I think it's enough points which is essential which will be essential for you to complete practice, and also will be essential to understand the example which I'm going to provide. And now we will move into statistical analysis basics. And we will start obviously with definition of statistics, descriptive statistics, hypothesis testing, and again, some automation tool available in spreadsheet. So in general, statistics is seen as a branch of mathematics which deal with collection, organization, analysis, interpretation, presentation of data. And if we're talking about medical statistics, it's obviously consider application of statistical principles and methods to medicine, health science, including epidemiology, public health, forensic medicine, clinical, and of course, and even on the first place, it's clinical research. So, and it's already considered as being almost independent branch of statistics science for already decades. And when we talk about statistics, we very often refer to term probability of that some events happens or not. But would be fine to keep in mind that statistics and probabilities, they are related but separate academic disciplines. And probability studied under probability theory, which is measure of likelihood that some kind of events occur or not. And key difference between statistics and probability that's shown below in this diagram, when probability, usually we are given model when some events could happen, and we need to estimate predict our data. In statistics, usually we have absolutely opposite case. We retrieve data from our experiments, we observe, perform acquisition of data from some instruments, And we are going to summarize this data, get some summary, get evidence about our assumption, about our theories. So we are given data and we want to predict model. Is it we are like have some uh, relationship possibilities or not? So here is statistics. I'll usually use probability distribution. So topics studied together, but they are not the same, not the same. Okay, so right now some key points for key uh, subjects which will be necessary again to understanding for the materials in this lecture. So as I already pointed, statistics actually could be seen as a tool for measuring of characteristics or sample group, selected group, or population group. So here is, in fact, population contain all members of group, like all students in the world, in country or in the world, or patient, and depending to circumstances. And the population we can see, like patient in clinics or citizens of inhabitants of city or citizens of country or even entire population of our planet. So again, depending to task. And the population we can see different amount and set of persons or objects. But if population become too large, usually in scientific research, we deal not with entire population, but with selected representatives, which is called sample or subset of population. Obviously, it's a significant question to create proper sample if we are allowed to do, if we conduct our own experiment, if we just supervise what is going on, like specific kind of diseases. So we will be given those samples that comes from nature. From like frequency, how often happens this pathology, how often it could be found among the general population. So, and when we want to analyze our data, we have to identify variables or those characteristics that can form different value from one observation to another. And during our experiment, we deal with independent and response variable, where independent those measures that can take different value and which subject for manipulation by researcher. So we can make control about some, it's our inputs when we change, no matter what is it we talk about, like we decide, for example, in simple case, we decide time interval for observation. So here is time will be independent variable. And response will be those measures not controlled, but it's just that results that source variable we are interesting into observation and evaluating, no matter if you're talking about something simple like blood pressure or ECG level, or we are talking about evaluation, some characteristics of pain, for example, in patient, or time to healing some wounds or something of this. So it is in this case important that time of healing become not independent variable, but in this case it's become a dependent variable or response variable, and might happen probably one of patient characteristics will be independent variable, for example, presence of specific pathology or specific symptom or something other. So in fact, it's points that have to be subject of even entire specific lecture to be evaluated, explained, and selected. So right now we just passed through, and in educational task you will be given example which is like carefully prepared and every time pointed their purpose, like is it an independent or dependent variable. In all cases, those variables could fall in one of two large group, categorical or quantitative. So is it like in fact, could we perform it's depend about what kind of analysis we can do on the all this group, or what kind of semantic of statistical calculation can be applied for this. And the categorical we consider mostly not numerical things, which could be again split in three categories like binary, nominal, ordinal, and on quantitative we usually consider only two subcategories, discrete and continuous variables. So on binary we are talking about two possible value, like yes or not, true, false, male, female, etc. And the nominal we have multiply different characteristics. And in ordinal we added the specific order for those characteristics. And only quantitative variables, when we talk about quantitative assessment, we talk about usage of numerical or even uninterrupted information stream. So more detailed about qualitative or categorical variables we can split. So, for example, here is we can talk about treatment group, exposure group, disease status, etc. As I already said, binary or dichotomous group have two levels, like the treatment placebo, yes, no, and etc. When we talk about nominal variables, it's named categories under which the order is insignificant. So, for example, blood type of patient, here as we can see as nominal variables, martial status, or so. In ordinal variables, order, we have like we deal with ordered categories where order is matters, like staging of development of any illness, like minor, moderate, severe, etc., or disorder, or grades. In fact, it's not like illness, but grades also ordinal variables. And not only this ratings A, B, C, D, but even those grades which I placed for you on classes, despite I use a numerical value to express like students' performance from 1 to 12 in Ukrainian style. All this, because of their meanings, they are related to ordinal variable. Despite I use numbers, it's by nature, by purpose, it's categorical ordinal variables. So very important point, which very often missed by people. When we talk about quantitative variables, it's usually simply some counts, amount of something. As a result, we can perform arithmetical manipulation on counts, and also time, which is on continuous uninterrupted variable. So here is obviously discrete numbers. It's limited set of distance values, such as whole numbers, like any statistics of any illness case in any country, yes, go complete and set. And continuous variables can take any numbers in defined range, like age or blood pressure, or set, like age or time that's uninterrupted. uninterrupted at point, same on pressure. But here is important point about continuous variable. When we use any kind of diagnostic equipment, we take, in fact, momentarily snapshot of this continuous variables. So we turn continuous into discrete. And actually, every time when we recording, for example, this blood pressure, we got specific value for this specific moment in time, and it will be discrete number. So nature of this signal is continuous, but our ability to recording turn it only to discrete. Same about ECG. We have our cardiovascular muscles contain have every time some electrical charges, which is change with each beat. But when we recorded it, we made some we make some measures a few times per second, for example, as you mentioned, but we would say discrete signal, discrete numbers. So here is exact point, which, because you already started with these things at your fourth topic, that was example about ECG recorded biosignals. So here is exactly this case. Continuous by nature signal. Moreover, periodical signal, which repeat itself with each heartbeat, but when we use any equipment to make recording, we turn it into discrete value, which presents those electrical potential of heart muscles. Okay, so now turn into question about starting with statistical analysis. And that's very interesting point every time I repeat, and it's my favorite when we talk about using statistical analysis. So try to use common sense, try to use logic for your conclusion and for your even for processing, because we have a lot of tools in statistics to be calculated, but usually only few of these characteristics will make sense. We can calculate a lot, but it's very often might happen that majority of them does not make any sense. Here is the problem, major problem and flaws in statistics, and source of multiply frauds, intentional or just unintentional errors at first place, but sometimes intentional frauds. Okay, second case, usually before we will start analysis, it's a good idea to visualize our data, and maybe we'll get insights. Usually it's help to make some insights from, to obtain some insights from visual information. And here is become obvious question to select proper chart type, proper type of graphics to represent our data. And here is huge point of confusion, especially with usage of spreadsheet, because usually it's very easy to create charts here, but very often students made mistake. For example, most common, most very popular chart type in spreadsheet, which is even spreadsheet itself every time proposed to use, it's like bar chart, line chart, etc. But the main problem that those chart type dedicated to display categorical variables, those chart type expect that independent variable or X, which is usually put through horizontal axis have to be composed by categories, not numerical categories like patient number or patient name, city name, or something like this, category name, group name, or so. So it expects that independent variable have to be categorical for this bar chart or line chart or so. And unfortunately, people very often try to use it for even in case when independent variable is discrete or continuous. Sometimes it's not make any harm depending to case, but sometimes it's affect results. In contrast, if we talk about visualization of continuous variables, so we have useful things like, first of all, it's specific statistical chart like stem and leaf and box plot. Those dedicated to especially box plot, stem and leaf visualize distribution of our data. As you can see, we have some example of how we form stem and leaf scheme of decimals, and then we use leaf to single values, which is expressed in this manner. Box plot histogram are dedicated statistical chart which histogram express frequency of occurrence in specific case, and it's very good for continuous variables, especially dependent to time. And box plot itself useful to visualize descriptive statistic parameters. So they are not just to visualize characteristics of data, they express statistical characteristics of data set itself. And if you want to see raw continuous data, so in this case, a good way is to use scatter plot. So here is again, if you want to summarize continuous data, that stem and leaf, box plot, and histogram useful. If you want to see, if we need to see raw continuous data, so here is will be choice is scatter plot. Also in materials of practical class 4, given some document, we're given document with some little bit more information about this, and I strongly recommend to check this. And now a few words type by type. When we have independent variable as categorical, it's very obviously to use bar or linear chart, and we will have like nice representation in this case. Number of patient which suffers from specific level of shock index, and in this shock index, obviously it's ordinal categorical data type, because order here is matter. It's significant difference between fast shock of first level or 10th level. With stem and leaf, we can like get a visualization of continuous data, and we have for example, usual case, it separates stored data into leading and trailing digits, depending to value, what do we have. So for example, how we can denote age of participants with stem and leaf, or how we can do it for something like similar case for male and female and got kind of statistical distribution in visual way. So in case if we have small samples, it's a good way to do it manually. But in modern time, when we have very large data set, for us very easy to collect large data set with computer system, stem and leaf become very rarely used methodologies, and in contrast, we turn into wide usage of histogram, which is display distribution of continuous variables. So here is again not exact numbers, but frequency, how often it's happen within a given time interval. So here is we have independent variable, in this case, for example, arrivals per minutes. Okay, no matter what we are talking about, planes to airport or like patient to hospital emergency department or so. It will be almost the same things. And here is we have, as you can see, we use 1 minute as distinguishing interval, but in the same case we can select yet another interval. We can use 2, 4, or 30 seconds or so. And amount of events which has happened with given interval placed into represent those bars. So here is, in this case, it's why we are talking about probability distribution. Probability distribution because it's depict probability it items happen. Jesus Christ. Oh, somebody starts constructional work at site. Nice, thanks. And at this point, it's time to turn into descriptive statistics itself and to define it. What is descriptive statistics? So it's summary statistics that's quantitatively describe and summarize features from collection of information. Descriptive statistics, as mass known, is process of using analysis of those statistics. So we have talked about under this term, we have to understand things and process, like what we can do and with which goals. So in fact, on the same term, process and results describe it. So actually we do descriptive statistics and we do descriptive statistics for our data set, and we obtain descriptive statistics characteristics for it at the same time. And it's distinguishing from inferential statistics or inductive statistics when to summarize a sample rather than data to learn about populations and data trogs represent. So with statistics, we only retrieve essential characteristics, and then question to apply our imagination to induct some assumptions, some ideas about what this data could mean, what it potentially could lead us to. About classification of descriptive statistics, we have identified at least 4 characteristics, but here is 2 major and 2 auxiliary. Major is central tendency and variation, so we identify a few characteristics which our data set stands to on the central tendency, or we can measure some deviation from this tendency. Also, we use quartiles to split data set into some parts and assessment shape of distribution. So when we talk about interval level data, measure central tendency and variation common descriptive statistics. So central tendency describes series, data series with single attribute, and measures variation describe how widely our data moments vary. And standardized scores combine both central tendency varies into single descriptions that's comparable across different samples with same or different units of measures. So when here is we have this standardization, we got abilities to compare and make conclusion about does we have some similarity or difference between our data sets. So here is important to understand, because every time when we measure the descriptive statistics from different sample population data, we will got like different exact numbers, different exact central tendency variation value. And here is question will be then, is it they are really different or there is no enough difference? So those standardized scores can give us ability to make assessment of this, but this actually it will be topic for hypothesis testing, which is based on descriptive statistics. And phenomenal ordinal data, which we used common methods, it's describe frequencies as compared to a total, which parameters, which fraction of total refer to specific value. So what is most common things, it's obviously mean, median, mode, which is central tendency characteristic, arithmetic average, point of scale below which 50% of score fall, mode, which is most frequently occurring value into our data set, etc. So how it's visually look like in data? Here is we have very small data set of variable which represent age or our x. So here is xy, it will be each score. We have number of score or sample size. I very often use term sample size for n. Number of scores, sample size is the same. Then we have sum, an arithmetic divide by number of scores give us arithmetic mean. We have median, we have mode because two value repeated there. Why it's important to have this few assessment, this several assessment, not only one, because of chance that each one single could be affected. And here is a good example of how we have this blue dots. It's our data set. Example, how easy mean could be affected. We have 5 item sample set, but let's say one we have very large value and it's immediately affect mean. In contrast, even presence of such extra value, which could be possible outliers or caused by errors in measure or so. So in case of median, it does not affect but this outliers. So if we have only mean, we can't be sure about exact characteristics of our sample. But if we have at least mean and median, we are more clear about characteristics. Like here we have mean, median, they are exact. So we are talking about something like symmetrical data set. And we have mean, median difference, so we have asymmetry, and it could give for us clue about presence of outliers or deviation or something might be wrong, might be okay, but just it's give for us clear insight that's about some skew in our data. So in variation, we can also have number of assessment like variance, standard deviation, coefficient, property range, etc. Range and so on. So here is we have why it's important. Again, I think it become obvious when you take a look at this frequency distribution. It's frequency distribution actually, and we see two symmetrical distributions. So again, in both cases, mean arithmetical average and median will be the same, but we have absolutely different variation for these two data sets, and here is depicted by frequency plot. So to make the assessment of it, we start with quartiles, which is we split out the set by 25%. So here is we have like four subsets, which each represent quarter of our observation. And from quartiles, we most useful assessments in quartile range. It's difference between third and first and third quartile. And so here is this one things. Here is we have like example where we place all these things. It's actually we introduce box plot here. We have maximum and minimum, which have to represent first and fourth quartiles. Then we have borders between first and second, second and third, second and third quartiles give for us median, and third and fourth quartiles give for us second border of interquartile range. So here is all these things, all this box has been introduced. And here is our real data, how it's arranged there. Okay. So if we talk about assessment of variability, so as I already talked, range, it's difference between highest and lowest value, variance, square deviation between individual scores, mean and standard deviation square root of variance, or representation of variation among scores that's directly compared to the F score. Okay, in the past time, it was not easy to starting to calculate this advanced characteristics. Like it's need to significant number of, and it's actually, I talking about simplest assessment. We have even more advanced characteristics. So it will be required number of calculation for that same best data set. We have much more steps necessary to be done. Thankfully for information technologies, we have used not only spreadsheet, we have available for us a lot of advanced statistical software, so we can get all this assessment at once once we have data. But again, I take this time to give for you insight about importance to understand what is actually characteristics we deal with, because that's important in making assessment and in decided about which kind of analysis useful. And again, similar way like with importance of few central tendency assessment, here is we have, why do we have, why for us important to have different variation assessment. So here is we have data set with the same mean, and here is we will have the same median, but different different variance, because again, depending to alignment of our data. So here is we have clear clue about how, so we have our data symmetrical and concentrated in center, so we have smallest s, and if we have significant variability in our data set, it will be larger, and so on. All these things, it's very useful to be depicted by box plot. Actually, most case, if you will read statistical articles, scientific articles which include statistical analysis, it's a very common case with box plot presented there, which depict characteristics of samples which were used in analysis. And here is we have, again, it's already shown that box representing the quartile range. In the middle, we have median for our data set. So we have assessment of minimum and maximum, not exact value, but assessment of minimum and maximum, which have to be given about 1.5 interquartile range difference between first and third quartile. And obviously, it might happen that our real data will be outside these boundaries, and so we will have outliers, real maximum and real minimum. So again, usually I just repeat usual statistical labels for those things, like sample population mean, that's labeled with different Greek characters, same standard deviation and sample population standard deviation, and variance, which is labeled by sigma or S. Practically, we will mostly deal with sample dataset and with sample labels. Okay, and a spreadsheet make our life much easier because it contains some function which allow for you to calculate descriptive statistical characteristics, or even automation tool. Automation tool to do it. Let me show for you brief example in spreadsheet. So first of all, about data set. Here is, as you can see, two set of the same numbers. But depending to how I describe my problem, those same numerical value will be representative of different data types. Let me see here, label spoken about nominal data. We measure some vital characteristics from different patients, which is organized in two groups. For example, we compare them taking medicine or compared to placebo, and we measure something. No matter what is this, blood pressure, or not too much for blood pressure, some kind of characteristics important. But each row represents a different patient. So patient, it's independent variable, and in this case, it's nominal data. So independent variable have nominal data type. So if we want to visualize our data, we have to use something, we allow it to use something simple like, well, for example, two-column bar chart or so. Here is in this case. Or we can do it by group if we want to do it. And it will be correct representation because our independent variable has nominal data type. On the other hand, if we are talking about let's say we have two patients only, and we make observation through time, and each second we recording some value from patient. Again, no matter what is exact value. So here is we are talking about discrete data time, because independent discrete data set, because independent, or quantitative data set, because independent variable have quantitative discrete data type. It's time in this case. And here is if we are talking about correct visualization, so the only scatter plot could be used, raw data, or we can join it with lines. If we need to measure for each patient separately development of this process, it's could be useful to visualize with even with different with lines. So here is exact case like a task 4, visualization of biosignal, visualization of ECG with spreadsheet. So it's why scatter plot only correct, because independent variable it's has numerical discrete data type. In contrast, if we want to compare one patient to other value, first of all, we have to be careful: is that it makes sense at all? Is that it comparable at all? That's we have to think about nature of this data. Obviously, it's useful then to create scatter plot, but line does not make sense at all in this case. So only raw data or raw data points which will be refer correlation between these two values. But again, we have to ensure that this correlation does make sense at all. Technically, we can do it. But is it make sense? Is it give us some clue? Dependent to what we deal with. When I back to our nominal data, when we are talking about statistical analysis inside group or for both group. So obviously, if you want to visualize statistical characteristics, that will be per group. We can use frequency plot, so we can use histogram without any problem, and it definitely will make sense. So here is system automatically made assessment and split us in our some groups, split our data set in specific groups. Actually, it's better to use more specialized software like statistics, PCC. In this case, you will have more controls about setting up intervals for histogram. Excel relatively poor in this case. But anyway, it's just an idea. So here is we have again, we have some classification of our observation for each group, how much patient fall into specific range, into a range that system defined by itself, how many patient fall into this group. Because again, okay, and most, but again, it's have to be used very carefully because independent variable, nominal, non-numerical, and in this case, I does not include independent variable. I only refer to my data set to dependent variable, so I consider frequency of dependent variable only. So here is in this case, in x-axis, we are range of characteristics we are measure, and frequency, it's the amount of patient which has these characteristics, which is important to understand, not patient number. X-axis right now, not a patient number. And finally, obviously, if you want to compare, if you want to get descriptive statistics for our data set and visualize it, that will be do we have box plot? Box plot will be obvious choice, and we can add would be fine to have legend to see which data set belong to each data. We can then add the data labels, also very useful. So here is in this case, as you can see, we have expected maximum minimum with this mustache. We have outliers, maximum minimum value. We have our interquartile range. We have median. So here is given characteristics for our value. Technically, we can do the same things for discrete variables, but here is will be questionable about again, no, box plot itself. Obviously, we can do, but does it make sense? It will have the same results like this case, but usually it does not make sense because of our observation, and especially if it's periodical signal. If it's non-periodical signal, okay, we can gather some maximum minimum from this. But if it's periodical signal, if we can continue our observation and we will retrieve again smaller and lower, or smaller than higher values, and then smaller than again higher, sorry, it does not make sense at all. And it's the reason why in previous case, descriptive in topic 4, I spoken about this, why calculation, visualization like this makes sense and give some clue insights about development of process, and attempt for calculate descriptive statistics does not make sense. Again, in this case, I can add this chart, but usually it does not make any sense and better to discard it. Same situation, we can add the histogram here. It's even make more sense than previous case, but if it's non-periodical signals, okay, we can talk about some usage of it. If it's periodical signals, it does not make sense. Technically we can do, but we have to understand is it makes sense because of nature of our data, nature of our observation. So same way if we talk about descriptive statistics in numerical representation, okay, it's good case to use data analysis tool. So here is we have things like descriptive statistics. I can provide my data set, organize in columns, have labels. I want to present result. Okay, new worksheet, and I need summary statistics. So here is it is. I have numerical assessment for descriptive statistics, and I can for our both group. Again, it will be reflect those value. It will be spoken about value I measured, not, and I can see that here is like average per patient. I have some average value. Have standard deviation mode per patient. If I do same calculation for this data set, definitely I will retrieve the same result. But in this case, it will be not about patient, not about group, it will be about patient. If I do the same calculation, sorry. As you can see, it's per patient. So for this patient, average value is given, standard deviation, median mode. Again, we have to understand, does it make sense? If it's non-periodical signal, okay, it might give us some clue. If it's something like something like heart rate, sorry, it will be absolutely useless. In case of heart rate, it might make sense because we have we have some normal level. So again, keep in mind that with spreadsheet or with more advanced statistical software, you can make a lot of calculation, but every time you have to understand, does these things make sense? So here is problem of statistics. Turn back and continue with hypothesis testing. So before we start with hypothesis testing, we have to a little bit more introduce about distribution. Statistical data set is listing of functions which show all possible value intervals of our data and how often they occur. So again, it's very similar to understanding of histogram. So frequency distribution is grouping of data into multiple exclusive categories, show number of observation in each category. So here is given example. And the most important point is a most important kind of distribution. It's a kind normal distribution, which is apply or for continuous distribution, or its application for discrete value, so-called students distribution in name of not students, but person with name student, scientist with name students. So we have numbers. If we talk about normal distribution, if we create frequency histogram by x-axis represent value of scores and distribution x-axis represent frequency of scores, and scores have to be similar, therefore we'll group near the center of distribution. Score have an unusual value and located far for uppers of distribution. So Features of normal distributions: symmetric and bell-shaped curve, half of score above and half below midpoint, curve asymptotic to x-axis but never cross it, mean, median, mode located at midpoint of H. And we have 3 sigma rule, which talking about how we can make assessment about exact normal distribution for population. Important sigma rule, 3 sigma rule, it's applied for population distribution, not for sample distribution. And it's have to be like this one, 68%. It's have to be within 68 within 1 sigma deviation from the center, 95 within 2 sigma, and 90, almost entirely data set within 3 sigma. But such as practically we usually deal not with population data set, but with sample data set. So sigma rule not in all case effectively to be applied, and we use some method which allow for us give more or less assessment about how closely our data to the data set. In generally, real data sets usually skewed left or right. We have, in that case, when we compare median to mean, we can make assessment about log assessment as it about symmetric or skewed assessment. And with help of histogram, we also could see this, repeat that same chart. We have see how our data set is skewed. So here is we have obvious left skewed distribution with tail at right. And by using based on distribution type, based on descriptive statistics features, we can start to deal with statistical hypothesis testing, or it's kind of statistical inference that's use data from sample to draw conclusion about population parameters or population probability distribution. And it's act in statistics variably list test an assumption regarding population parameters. So when we conduct scientific experiment, we have an idea about what we are going to expect, and this idea it will be our hypothesis for testing. And as a result of data processing, for statistical hypothesis testing processing, we should, let's say, confirmation that we are true, or might happen we have to be wrong. Sometimes it's happened. Same way when we analyze some historical data, retrospective analysis, we have some clue about presence of specific pathology or some new outcome, and we verify existing historical data to get evidence are we are correct or not. In order to typical assumption when we start to perform statistical hypothesis testing, that we have normal distribution, randomly selected our data set, sample estimate is compared to underlying distribution, sample size, sample distribution, and then we determine probability that sample estimate reflects the population parameters. So in case if we talk about interval ratio data, or I mean quantitative data or discrete data set, we use test statistics, Pearson correlation, ANOVA, regressional analysis, etc. For nominal ordinal data, we use different of proportion, chi-square test, and different assessment. In fact, it's not easy. It's usually difficult process and difficult steps to pass through statistical hypothesis analysis. So if we talk about rogue steps and draft of algorithms, will be something like given in this slide. We look into data and decide about general statistical model. So we deal with categorical or quantitative data set. Then we state null and alternative hypothesis. So that is the point where maybe majority of students made their error. They it's hard to imagine that we have to make our assumption before we analyze data. We analyze data in order to get evidence of our hypothesis. So we must create this assumption before made calculation. Then we decide about useful statistical tests, dependent, for example, distribution type. Then 4 steps, easiest part, calculate it. And also we have to obtain not only result of statistical test, like parameters statistical of descriptive statistics, but also significance, how strong this results. Here is again difficult point because we need a special function or special software or special tool to determine significance. It's most important point. And here is we decide, we check about our significance level, which is usually at least maximum 5% in scientific research, and in modern research, and even less, like 1% or less than 1%. So it's like margin for error. If probability that we are wrong, which is significance, probability that we are wrong, less than this margin level, we can compare our calculated statistical value to some critical or so-called reference value, and then accept or reject our hypothesis. In case if our probability of error significance greater than margin, we can't make exact conclusion. Too big chance to be wrong. So we can't nor reject null, nor accept in favor of alternative, nor accept null. We just report result our studies. So here is also difficult point to say. Again, recap. We've looked into data, decide about statistical model, then we check. So what we analyze, like mean, variances, or something as an independent variable, dependent variable also. Then we create 2 hypotheses, null and alternative. It's important, 2. Then we decide about useful test. Usually depend to distribution type also. We calculate it, we calculate significance value, and we make decision. Does we have ability to make conclusion, exact conclusion, or we are not precise enough? More detailed, let's expand the steps. First of all, what kind of variables that we measure, dependent variable in this case, dependent, categorical or continuous. In case of categorical data, we compare proportional in groups. So for example, we use chi-square test as most common case. In case of continuous data, we have more harder situation. We compare mean or median in groups, depending to groups, 2 or 3 or more. For 2 groups, we usually use, depending to the distribution type, we use test statistics, Wilcoxon test or so. For 3 or more groups, we have to use things like analysis of variances or ANOVA, or Kraskov-Wallis test, or something similar if it's not normal distribution type. Why so complex? It's because here is we have multiply appropriate methods for hypothesis testing. So all these methods represented by formulas, but usage depend to condition. Like it's have to be useful. Is it what we can do? Compare control experimental sample, like people's patient, 2 groups of experimental patient given medicine or placebo. So here is control experimental groups. Or what we observe, same group of patient before taking medicine or after taking medicine. So it's turned into compare sample before and after experiment. Or if we want to prove that taking medicine bring like blood pressure to normal level. So it's mean compare sample mean to constant. So here is we have same very similar question, which led of us to absolutely different statistical model. So here is statistical model like compare independent sample, compare dependent sample, compare population mean to sample mean. So here is this case. It's statistical model. In fact, that I spoken about statistical model. So here is second column statistical model, and then condition distribution type. If we have normal or abnormal distribution, first case we additionally test variance, and then we have to come into single cell, which give for us the only correct method for this case. Here is main difficulty. When you pass through this algorithm, you must come into only single cell and prove that it's the only correct way to make statistical analysis. About some technical aspects, that's null hypothesis and alternative we formulate in very different way, like no difference between two parameters, it's like sample mean or sample variance, depends to what is subject for our study. And we have to explain practical outcome, what it will be if like means equal or does not equal. And same alternatives, there is present significant statistical difference between these parameters, not arithmetical, statistical difference. And again, practically it means sign. And rejection criteria, that's margin, it's alpha. I already explained what does it mean. So if we have two great significance, to great probability of made mistake, we exceed rejection region of rejection, so we can make this conclusion. And here is could be how it could be depicted when we have like null hypothesis equality between parameters, and alternative we have less than. It's like left-tailed test. So here is will be our alpha level, and in this area we'll have evidence to reject null hypothesis in favor to alternative. At right side, we are not sure. We does not have enough evidence to make conclusion. More simpler, more not simple, actually, in fact, more difficult case, but sound more simply when we consider a case equal does not equal, null hypothesis state parameters equal, alternative not equal. We split our region in two. We have two areas for reject null hypothesis, and in between, we are not sure. We does not have evidence to make conclusion. And all these three cases combined together, left-tailed, two-tailed, and one-tailed test. How it's have to be formulated. It's only about how we formulate null hypothesis. Pay attention that we use population mean in this case, population mean. So in generally, test statistics applied to continuous variables, and we spoken about population parameters. So if we reject null hypothesis, we conclude that there is enough evidence to infer the alternative hypothesis to fail to reject. It concludes that there is no enough evidence to infer that the alternative hypothesis is true. But also it's not, there is no evidence that null is true. That's I told that here is we have our problem. And here is we have like two, we can fall into type 1 or type 2 error when we type 1 when we reject true null hypothesis, and type 2 we don't reject false null hypothesis. Easy to determine for fun, like in this case, but in reality, when we deal only with numbers, it's not such a fun, and it's really very difficult to determine is it we have is it we fall into null error or does not? And especially in even more difficult with type 2 error, when difference is so small, it does not matter. It's much is very hard to detect or big enough, but sample size too small. So here is a very common case when we deal with very small size, and we does not have evidence in this small sample, but in reality, it happens. And here is we have outcome in case is it result is statistically significant or not. If our significance level less than 5%, it's significant, and if exceed 5%, that's we have too big chance to be wrong. And here is the same things on this chart. Is it overwhelming, strong evidence, or weak evidence? With overwhelming evidence, it's have to be very careful. It might indicate potential potential weakness in our analysis. So a spreadsheet contains some tools to automate this analysis, like test statistics, F statistics, ANOVA, and so on. So actually we have few automated tests, and our software, our Statistica SPCC, other products even better in this case. So just quick example, we have last 5 minutes, just quick example. So here is, we are going to, with this data, with this task, we are going to prove that there is significant difference in hemoglobin erythrocyte level of people of different gender. For men and women, that difference is significant. So first of all, we have to formulate null alternative hypothesis, like no, there is no difference. Or first of all, statistical model. Definitely, we compare two independent samples. Men's and women's, male and females, are independent samples. So it's first class of analysis in the table I have shown for you. So statistically, we will spoken and compare sample mean in two independent samples. Compare sample mean in two independent samples. After that, we will have formulation of null hypothesis, like will be spoken, there is no sample mean. Practically, this will be conclusion. We will have to conclude that there is no significant difference between the hemoglobin, for example, for people of different gender. Alternative hypothesis will spoken that's present significant difference in sample mean for men and women, and practical meanings present significant difference in sample mean, and practically it will be difference that's yes, or in this case, hemoglobin parameters, hemoglobin level depend to gender. Okay, then we have to evaluate null hypothesis. For this, skewness and kurtosis could give for us assessment about how is it possible deviation from normality. Is the distribution normal or abnormal? In fact, here is we have calculated this for value by using descriptive statistics or by formulas, and then compare to critical value, which from special statistical data set. And then we decide about, is it, here is we have very small value, so I not provide this value, but in fact, distribution type here is normal. Then we have to make the assessment about variances. Pay attention that here is we have greatest variance for first variable, so we have to provide it in given order. If it would be in reverse order, we have to change this order. And finally, when we got this test statistics and F statistic and test statistics. So about F statistics, first of all, F we have, so again, null hypothesis, no difference in variances, alternative, difference in variances. F less than critical, so we have to accept like no difference in variances, but significance 0.44, 44% of error. So there is no evidence is we have difference of variance or no difference in variance. Anyway, we start with the statistic for equal variance, and here is we got completely different result. Test statistics for we compare like equal, not equal. So we use critical we use significance to tail it and critical to tail it. Test statistics are much greater than the critical to tail it. So it looks like we have to accept, we have to reject null hypothesis. Let's check test significance, 0, 3, 0, 3.4. So it's much less than alpha, significance much less than alpha, test statistics greater than the critical, means difference in mean is significant, and yes, in this case, people's hemoglobin depend to gender. If I would get back to my example, so here is I have calculated those value. Here is we have the same things. If we decide to compare like parameters, is that we have difference between group 1 and group B, in this case, observation, we should follow the same pattern, no hypothesis, like there is no, again, such as we have independent variable patient, so we have control experimental group, the same kind of statistical model. So we compare mean in two independent sample. No hypothesis, there is no difference in mean. Alternative, there is present difference in mean. Here is we have like skewness kurtosis. Let's say again, we have two very small value. I have to show for you this table, but right now, like only one value probably exceeds this problem. Here is this one. This pair very small, and definitely fall under normal distribution. So one variable under normal distribution, second closer to it. If we talk about usage, take a look at this, variances. Take a look at variances. Here is we have second variable greatest variance. So if you want to calculate, if you need to calculate, perform variance test, let me just pass this 1 minute. We are already over time, 2 minutes. Let me just pass this. If you want to calculate variance test, you have to follow it. First of all, you have to use second group, then first, because every time first Fisher test, we divide greatest variance by smallest. So first must be those sample which has greatest variance. And output, okay, new worksheet. Here is do we have, here is correct result, greatest variance, smallest variance. So here is we have F statistics greater than F critical, and we have very small, very good, we have very small significance, F greater than F critical, so we reject the hypothesis and we have difference in variance. So if we want to use test statistics here, we have to use test statistics for unequal variance. We have enough evidence, and here is we have use greatest. Where do we have greatest average first variable? Yes. First variable, sorry, just last minute. First variable, second variable, labels, okay. So here is do we have again significance, we consider to tailor test, again significance very small, our far below 5%, our test statistics greater than the critical, so again we are talking about rejecting null hypothesis in favor to alternative, and so we have evidence that those parameters significantly different between groups of patients. those parameters because I don't know exact name. So actually that's all I can manage to present for you right now. Thank you for your attention, and we will have something similar topics at tasks at practice. Goodbye, have a nice day, have a nice classes.